Now that I've introduced the different types of data that we work with in GIS and the different measurement scales on which we measure data, I want to talk a bit about cartography. So cartography is just the study and practice of making maps, and even though this is just an intro level course and you've only made a handful of maps so far, it's important to think about these things. So why do we even make maps in the first place? The point is to transmit spatial information to a map reader. And so in order to do that, your map has to be clear and effective. And ideally, you want it to be aesthetically pleasing. You want it to be simple and easy to read to effectively convey information. So cartography is about deciding what you want to communicate, to who you want to communicate, and figuring out the best way to do that. You can have the most interesting data analysis ever, but it's meaningless unless you can convey your results in an understandable and accessible way to your intended audience. I want to talk a bit about data symbolization, the shapes, characters, colors, lines that we use to represent our data and inform others about our maps. So some things that you need to think about when symbolizing your data are, is it discrete or continuous? And what type of measurement scale is it on? If you're working with discrete data, so something like the location of a particular tree species or roads, you can symbolize data in one way, whereas if you're working with continuous data, that's something that has no inherent boundary, whether it's population density or rainfall, maybe you need to represent it in a different way. If you're working with nominal data like tree species or land cover or dominant language, you need to make certain choices, whereas if you're working with qualitative data, either interval or ratio, you have to make other choices. So if you're working with population density, tree density, disease rates, or temperatures, you'll display your data differently. When representing discrete phenomena, it's best to, generally speaking, display it with vector data, best represented with points, lines, or areas. So the shapes, the colors, or the lines represent types of different categories. So for instance, here we have a map of tree species in Vancouver. And so you're using different points that are in different shapes that are also in different colors to convey what the different species of trees are to the map reader. So it's pretty obvious that a red circle is no more or less than a blue triangle, no more or less than a yellow diamond. It's just different, right? Because the tree species are just different categories. There's no inherent ranking to them. You want to avoid using like graduated symbols or gradations of colors for different categories because you can imply meaning or you can imply ranking or scale that doesn't actually exist. So if you're displaying it with polygons instead, say you're doing the most common tree species by neighborhood, it's best represented by colors that are in different hues, not in different like shades of the same color, right? Because you want to avoid implying some sort of magnitude. So it's pretty obvious from this that there's no ranking, whereas if you did everything in a shade of green, then you might think, oh, is this tree height or tree density, and imply some ranking that doesn't exist. If we're looking at quantitative data, whether it's interval or ratio, it's generally better to use colors that vary from, say, light to dark. So you grade across one color, different shades, or you can use graduated symbols. So for instance, this map is showing tree density in Vancouver by neighborhood. And so tree density has some numeric value tied to it. And so we can use light shades to represent less tree density, darker shades to represent more tree density. And it conveys to the map reader that there's some inherent ranking to it. And we can also represent continuous phenomena with graduated symbols, varying by size. So we did that in lab 1, for instance, with the cholera deaths, where the sizes of the points increased when there was more deaths at a certain property. Another example would be, we'll look at this COVID map from Johns Hopkins. Looking at this map here, they're looking at COVID cases, which is, again, a type of ratio data. It starts at 0 and goes up. It's quantitative. Instead of using gradations of the same color, they're using point markers of different color or different sized circles to represent COVID case totals by county in the US, for instance. And so you zoom in and you see that the points are all scaled based off the relative number per county. Higher numbers of cases correspond to larger circles. So as I mentioned, you want to use different hues for nominal categorical data. You want to use different shades for quantitative data. So this is an example of what not to do. If you make a map of the most common tree species in Vancouver and you use some gradation of all the same shades of green, you imply some ranking that does not exist, right? So a red maple is not more than a Norway maple, but based on the color scheme presented here, the map reader might be tricked or misled into thinking that it is. If we do the same with street tree density, representing a map with this rainbow shade of colors for some variable that grades in intensity isn't good either, because it makes it very difficult for the map reader to interpret. They have to constantly refer back to the legend, right? So the category 1, 483 to 851, is just below 851 to 963, but looking at the map, it's very hard to tell what the actual order is for these categories. Beyond that, it's very important to just generally speaking think about color. Color is the primary method with which we use to convey information on a map. And some colors tend to have implicit associations, at least in certain contexts. So for instance, blue is typically associated with cooler temperatures and red is typically associated with warmer temperatures. So if you were making a map of average temperature across some region and you used red to represent cold and blue to represent hot, you're going to confuse people just based on the pre-existing connotation or association with that color. Now, in different contexts, it might not be as relevant. If you're making a political map of the United States, it's important to be aware of the fact that blue is associated with Democrat, red is associated with Republican. Many contexts, gray or tan or green are usually associated with land, whereas blue is used to represent water. So you want to try to avoid representing land areas as blue if distinguishing between land and water is an important aspect of your map. If that's not important and you're trying to represent some other variable entirely, maybe it's fine to use blue to represent your land area. So again, just to kind of summarize things a little bit and build on that, a sequential color palette is one where you grade from light to dark within the same color. So you have shades of the same color. So you might use a light value to represent less of something and a dark value to represent more of something. Diverging color palettes are useful, again, for quantitative data when the departure from a middle value is somehow important or meaningful. So say you're making a map of sea surface temperatures and you're trying to represent their deviation from normal, right? So maybe you're making a map of sea surface temperature anomalies to show an El Nino versus a La Nina, right? So the average would be gray, and then increase above would be one, and a decrease below would be another color. Or if you're trying, as this color scale shows, to represent deviations from mean rainfall. So if you have increasing rainfall with climate change, you might use blue to represent that zone on the map. Decreasing rainfall with climate change would be represented by red. And no particular change would be some neutral shade of light gray. Whereas qualitative palettes, so that's different hues that are generally speaking all in the same shade or same intensity, are good for representing things that are distinct, that have no ranking. So different types of candy, for instance. There's one candy is no more or less than the other, so you use the same shades, but in different hues. And again, hue is just another word for color, so like red, green, blue, they're all different hues. Additionally, it's very, very important to be cognizant of accessibility when mapping. So about 4.25% of the population is colorblind. So there are a variety of different types of color blindness, but the most common one is red-green color blindness. So generally speaking, you want to avoid having gradations between green and red on the same map. So this image below shows an example of what a red to green color gradation looks like for someone who has color blindness. So typically speaking, you want to avoid using red to green gradations. You'll see examples of this in cartography all the time where people just don't think about it. And it doesn't affect 95% of the population, but it does affect a fairly sizable subset of people. So there's 50 people in this class. Chances are 1 or 2 are colorblind. If you're making a map for a population of 1,000 people, you might encounter 40 or 50 people who can't see it. So a good resource for checking when you're making your maps is this website called Color Brewer. So this site allows you to pick out different color maps. You can say I want sequential or diverging or qualitative. You can set the number of classes that you're working with, and then you can say pick different options. You want to make sure it's colorblind safe. So this is a good place to reference. So every sequential color map you choose is going to be colorblind safe because you're just grading in shades of one color. So it doesn't really matter what color it is. Whether or not the person can distinguish between whether it's green or red isn't important because they're all in the same shade. But if you're using diverging color maps, it does become more important, and you see that checking colorblind safe would say, for instance, remove this red to green gradation. It's much safer to stick to a red to blue, for instance. Or if you're using a qualitative color palette, this is where it really becomes tricky. It really limits the number of options, and if you try to increase the number of classes, then you'll have more, and you can only go so far with maintaining colorblind safe accessibility. Say you have a qualitative color palette of 5 different categories. Unfortunately, there just really aren't any color schemes that are going to be perfect for that because you have to have some degree of red and green in there to distinguish. But taking it beyond that, you can also select colors that are going to look good in print or that are going to be photocopy safe. So there's different options